All right, in 6.3, we saw the example, we talked about the example 2 to the power of x equals 8, right? And we tried to imagine how to solve for x. In this case, we know that x is 3 because we just know our roots, right? We know our indices when we're taking radicals. If we had 2 to the power of x equals 5, 8 is a perfect cube. 4 is a perfect square, but 5 is not, right? 2 to the power of something is 5, but it's going to be a decimal that goes on forever. It's not a whole number, right? Today, we are going to solve this by using the inverse of the exponential equation. Remember, we talked about inverses on Wednesday. You know what they are. Multiplying. The inverse of multiplying is dividing. The inverse of adding is subtracting. The inverse of taking an exponent is taking the index of it. I think I should put a 2 here, right? Okay, the inverse of an exponential function is a logarithmic function. They're on your calculator. There are 2 different spots. There's this button. Well, there's more than 2 different spots, but there are 2 different types of logs. Okay. There's this one. And then there is where is it? Then there is, oh, sorry, it was right below the log. I was looking on the special buttons. That is called the natural log. Natural log is related to E. The regular log button is uses a base of 10. So it's talking about the exponent 10. Good? All right. So when we raise something to the power, we can undo it. We can undo the exponent with a logarithm. So the logarithmic function with base a, denoted by y equals log base a of x. This is communicated as log base a of x. Read as y is, oh, dang it. Read as y is the log base a of x and is defined by y equals log base a of x if and only if x equals a to the power of y and x is greater than 0. Good. So we're going to learn how to convert between logarithmic and exponential form so that we can see how to undo to the power of x equals 5. Good. Important thing to note, we know they are the inverse of exponential equations. And you cannot take the log of a negative number. So we said the log base 10 of 100 is 2, but the log base 10 of negative 100 is a non-real answer. Your calculator will tell you that you can't take the log of a negative number. So if we know that 1.6 to the power of 3 equals w, then how do we put this into logarithmic form? Right? Like, do you remember in elementary school when you had the fact families of 4 times 3 is 12, so 12 divided by 3 is 4? That's what we're talking about, the fact family between exponential form and logarithmic form. Good. If your variable's in the exponent, use a log to find the answer, find the value of that variable. Good. All right, so if we had, let's talk about this, 2 to the power of x is 8. If I want to convert between exponential form and logarithmic form, let's talk about what each part is. This is the base, right? And this is the exponent. what you need to do is start with the base and move it in a circle. So 2 to the power of x equals 8 becomes log base 2. So just like 2 is the base here, 2 is the base here. Log base 2 of 8 is x. That is how I'm going to convert. Okay, what I'm doing, the easiest way to remember this is I'm starting with the base and moving in a circle. So start at 2, write the word log, start at 2, then go to 8, then go to x. You're gone in a circle. Start base 2, go in a circle, so jump to x, come back over to 8 if you're converting back. All right, let us practice right here. Start with the base, move in a circle. 1.6 to the power of 3 equals w, then log base, right? What's our base? Our base is 1.6. Go in a circle. The next thing I encounter if I'm going in a loop is w, right? So it's going to be log base 1.6 of w. Keep going in my circle. 3 is 3. Start with my base. We'll write the word log. Start with my base. My base is e. Log base e of 25 is u. Start with the base b. Log base b of 27 is 5. That is from exponential form to logarithmic form. Now, from logarithmic form to exponential form, same, okay? Start with the base, go in a circle. Log base b of 8 equals 3. So I'm going to start with my base. Base is b, just like the base is b for the logarithm, the base is b for the exponent. If I'm going in a circle, I'm going to raise it to the exponent of 3 and set it equal to 8. Good. Start with my base. I think that's supposed to be an e, right? My printer. So I'm going to start with my base, go in a circle. E to the power of -2 is c. Here my base is 4. 4 to the power of w is 6. This is just practice because we're not making it any easier, right? Because now we still have a w in the exponent. Here we have a variable in the base. We want the variable over here, right? Okay, so the first set of skills was just switching between the two, right? We feel confident to convert between logarithmic functions and exponential functions. Now, if we have something like log base 3 of 81, you're welcome to put it in your calculator. Or we can convert it to exponential form. Find the exact value by converting to exponential form, okay? Let's talk first about how to put it into your calculator. I have a Texas Instruments calculator. On a Texas Instruments calculator, you can go to Alpha, which is your green button. Alpha, Window. Window is also table set. And then choose number 5. It says log base. Okay, and then it looks just like it looks when it's typed on paper. So that was log base 3 of 81. Good. It allows me to put in a base of 3, arrow out of 3, go to 81, hit the enter button, and the answer is 4. Okay. If you just have a log button without the base, that's fine. It will work. Okay. It is an understood log base 10. So if you have a log base 10, this one's a log base 3, this one's a log base 5. If you have a log base 10, it will work in your calculator as just the log button. However, you can use the change of base method to use log base 10 to determine what log base 3 of 81 is, okay? To do that, what you want to change this to is, in your calculator, log base 10 of 81 over log base 10 of 3. So you take the 81, put it in your calculator, and then you divide it by your base, the log of your base. Is that okay? Let's try it. So we know the log base 3 of 81 is 4. The log of 81 divided by the log of 3 should also give us the number 4. So that's what you do if you don't have the actual little button that says base. Good. Here looks a bit more complex, right? 125 is your term. So what we're going to do if we don't have, if we only have log base 10 on the calculator, is log base 10 of 1 over 125 divided by log base 10 of 5. So log of, 1 over 125, was that what it was? Divided by the log of your base. Good. Or again, alpha window 5. Alpha window 5. Log base 5 of 1 over 125 is -3. Or we can convert them to exponential form, which is what they actually asked us to do, right? So we said that this was the number 4. And that this one's the number -3. What if we converted it to exponential form? Log base 3 of 81 equals, I don't know, right? So if it's I don't know, I'm going to put the letter x. Now, let's convert to exponential form. Start with your base. 3 to the power of x is 81. If it's a perfect square, a perfect cube, a perfect 4th root, that'll work, right? So then I'm just, 3 to the what is 81? 3 to the 3rd. 3 to the 3rd. No, 3 to the 4th. Yes. So x is 4. Here we got log base 5 of 1 over 125 is, again, I don't know, so I'm going to say x. Start with my base, 5, go in a circle to the power of x is equal to 1 over 125. Good. What is 5 to the what is 1 over 125? Well, 5 to the 5 squared is 25, right? 5 to the 3rd is 125. So 5 to the power of -3 should be 1 over 125, right? Based on the rule of exponents. So that x is -3. You could either use your calculator or you can use converting to exponential form. That is how to solve a logarithm. Now let's talk about that other button, LN. LN stands for natural log This guy's called the common log. The guy right next, oops, sorry. That guy's called the common log. The guy right next to it, below it, who I couldn't find, is called the natural log. The understood base of 10 is the common log, and then the base of e is the natural log. Okay? So, to solve logarithmic equations, convert to exponential form. Here we have log base 5 of 3x minus 4 equals 3. Log base 5 of the quantity 3x minus 4 is 3. Good. Okay. Is convertible to exponential form. Start with your base. My base is 5. 5 to the power of 3 is equal to all of that. 3x minus 4. Good. So I've now converted between logarithmic form and exponential form. Now this is just an algebra problem, right? I have 5 to the third equals 3x minus 4. 5 to the third we just covered is 125. That means 125 is 3x minus 4. I'm going to add 4. And I'm going to get 129 is equal to 3x divided by 3. Get 43. X is 43. Good. And if I put that back in, log base 5 of 3 times 43 minus 4 . 125. So the log of 125 divided by the log of 5 is 3. I can check my answer. Good. All right. Second one, we are converting to exponential form again. Now we have a log x. Log base x of 81 is 2. Good. I wrote it too high, but I can convert it. Start with my base. X to the power of 2 equals 81. Good. All right, now it's again just algebra. If I want to get rid of the square root, or sorry, if I want to get rid of the perfect square, I just take the square root of x. Anything I do to that side, I have to do the other side. So it's the square root of x squared over here. It's the square root of 81 over here, but remember you have to do the positive and negative square root of 81. X squared just becomes x, and that becomes positive and negative 9, right? Because the square root of 81 is 9. So we have two different answers. X is negative 9 and x is 9. It's important that we put these back into the calculator, or sorry, into the equation to make sure that this is true, okay? Is the log base 9 of 81 equal to 2? Log, so remember, you're welcome to use the regular log base button, but log of 81 divided by the log of 9 is 2. The log base -9 of 81 should also be 2, right? It is not, because you cannot have negative logs. So we just say that that is not a real answer. It's just 9 because we checked it and it's an image, not real. It's not a real number. So that's the second example. The third example is an exponent, and we want to convert to log form. Good. All right. The third one, e to the power of 3x is 7. Good. So I'm going to begin by converting. Start with my base. My base is e, so I'm going to write log base e of 7 equals 3x. Good. Remember, log base e is the same as natural log. So I'm going to, in my calculator, it's written as ln. So I'm going to call this the natural log of 7 should equal 3x. Okay. If I put in, you can just check, is the natural log of 7 a nice number? No, it's a crazy decimal. So I can just keep solving for x and leave it as the natural log of 7. So x is what being multiplied by 3, so I'm going to divide it by 3. And my answer is going to be that x is the natural log of 7 over the number 3. If I put that into my calculator, is it correct? 3 times the answer. Do I get 7? I do. Fourth one, we have e to the power of 2x plus 5 is 8. Again, we're just going to convert. Begin with a base. We have log base e of 8 equals 2x plus 5. Good. Just like we did with this, we're going to take log e and turn it into the natural log. So now I have no space to write, but I will put it down here. Now I have the natural log of 8 is equal to 2x plus 5. I'm just going to, instead of changing this to a decimal, just call that what it is. Subtract 5, subtract 5. And what I get is the natural log of 8 minus 5 is 2x. Good. One more. Now I'm going to divide by 2. My answer is going to be the natural log of 8 minus 5 over 2 is x. Negative 1.4603. So can I say that all of that times 2 plus 5 equals 8? You can't. Good. And finally, a real life model for an exponential function. All right, this is the number the number of people in a college community who have heard a rumor. So the number of people is equal to the total population P of the entire school community. D is the number of days that have elapsed since the rumor began. So the number of people in a college community who have heard this story is equal to the total population multiplied by 1 minus e to the power of negative 0.15 multiplied by the days that have elapsed since it began. Can we convert this to an equation? We can. So P is the population. The total population. Good. D is days. Since the start of the rumor. Since the origin. So that's 1,000. Days is what we are trying to solve for. How many days before 450 students have heard it? So our total population is 1,000, and then N of D that's the number of people, right? We're saying, oh, sorry. People who've heard, and that's 450. So I put 450 here is equal to 1,000 times 1 minus e to the power of negative 0.15 times something I don't know. So this is where a logarithm will come in handy because we can't solve for a variable that's in an exponent, which is what we talked about on Wednesday. Good. So let's just replace these numbers into the equation and then we can convert to logarithmic expression, because logarithmic function, because this is a exponential function. 450 for the ND is equal to P, which is 1,000, times 1 minus e to the power of negative 0.15 times d. Good. Is there anything we can do to simplify? There is, right? This 1,000 is being multiplied by both the 1 and the negative e, right? So I can distribute the 1,000. That's now 450 is equal to 1,000 times 1 is 1,000 minus 1,000 times e is 1,000 e's. Good. Why would I do that? I want to isolate the e. Yeah. I want to isolate the e because the e is the thing with the exponent. So if I want to isolate the e, let's move the 1,000 over and then divide by this 1,000, right? So that's a positive 1,000. I'll subtract 1,000 from both sides. $450 minus 1,000 is negative 550, right? Good. Now I will divide both sides by the negative 1,000. Negative 550 divided, oops, negative 550 divided by negative 1000 is 0.55 positive. Negative divided by negative is a positive, so we just have 0.55 is equal to e the power of negative 0.15 times d. Good. All right. This is the simplified exponential equation. I got e alone because the exponent deals with e alone. Now I can convert it to a logarithmic expression so that I may solve it. Start with your base. Your base is not the 0.55. Your base is e because the base is attached to the exponent, right? That we want to solve for. So I'm going to flip it around. Base. Begin with my base. So that's log base e of 0.55 equals negative 0.15 d. Good. Log of e becomes the natural log of 0.55 equals negative 0.15 d. Good. All right. Just like we did before, we don't need to figure out what that number is. We just need to divide it by negative 0.15 divided by negative 0.15. Good. And what we get is the natural log of 0.55 over negative 0.15 is the number of days. Because we know that D stands for days, this doesn't make sense as a unit, right? Or days is our unit, so this isn't a number of days. So we should put it in the calculator. If you get like 7, that'll be 7 days. If you get 3.5, 3.5 days, right? Because natural log of 0.55 over negative 0.15 is not easily understood in terms of days. So let's just put it in our calculator. The natural log of 0.55 divided by negative 0.15, 3.9855. So I'm going to call that 4 days. Good.